Yeah. So any questions from yesterday's class? Okay. So let us start. So in the mechanics, in that Lagrange's and Hamiltonian equations. So we have discussed the concept in the previous class. So in that actually what we learned is d by dt of dou L by dou theta dot or q dot in general minus dou L by dou q is equal to 0. So this is Hamiltonian equation of least action. So this is the fundamental principle which goes the law of mechanics. So where L is given by T minus V, where T is the potential energy, T is the kinetic energy, and V is the potential energy. Got it? So from this actually we solved one simple equation. Let us take one more, the simple pendulum. So the case of simple pendulum. So for the case of simple pendulum, wherein if the ball is attached here and this one, the ball is thrown like this. So this is the ball. So let us say the mass of the ball is m and the length of the string is L. Then based on this understanding for the simple pendulum, can you prove that the equation of the simple pendulum is d square theta by dt square is equal to minus k theta? So this is the equation of the simple pendulum, right? Got it or not? Yeah. So can you prove this simple pendulum equation based on Lagrangian equations? You try on your own first. Let us see how it comes. So what you need to do is, see, I think you joined late, Samrin. So there is a simple pendulum. That simple pendulum, so with the help of Lagrangian and Hamiltonian equation, that is dou L by dou q dot d by dt of minus dou L by dou q is equal to 0. This is Hamiltonian equation of least action, where L is given by T minus V and T is the kinetic energy and V is the potential energy, right? So based on this understanding, for a case of simple pendulum whose length is L and mass is m, so there is a ball that is attached here which is the mass. So with this understanding of L and m for a simple pendulum, can you prove that d square theta by dt square is equal to minus k times of theta? So this is the equation of simple pendulum. We need to, so this actually with the help of Newton's laws, if you try to prove this, you are going to get this. So that is with the help of Newton's laws. But the same thing with the help of Lagrangian equation, you will be able to prove the same thing. So now actually I am asking you to do that. So find the kinetic energy, find the potential energy, and then find out dou L by dou q dot, dou L by dou q, and substitute in this equation. You are going to arrive it. That is as simple as that. Got it? So what is the kinetic energy of a moving ball? What is the kinetic energy associated by this particular ball? So the Ke, right? Can somebody tell me what is the kinetic energy associated with the ball in case of simple pendulum? So T is given by half mv square. where V is, so L times omega. So this is of M, so L omega whole square, or this is half M L square omega square. Now the same thing, half M L square and omega square can be written as theta dot, right? So where theta dot is d theta by dt, so this is nothing but omega. Got it, Deepak? Similarly, the potential energy is nothing but V, which is given by mgh, where the standard position of this particular ball is this one. Now, this is the height raised by the ball after the movement. Now, this h value from here to here is given by, so let us say if this angle is theta, then L minus L cos theta. So, h is equal to L minus L cos theta. So, this is mg times of L into 1 minus cos theta. So, this is the potential energy V. And then based on this, the Lagrangian can be written as T minus V, which is given by of M L square theta dot minus mg times of L into 1 minus cos theta. So now actually a function of theta dot and theta. Got it? Yeah, you are right. Theta dot square. Got it? So once you arrive at this equation, substitute in this and then try to get the value of the equation of motion. So dou L by dou theta dot dou L by dou theta dot is given by, so you have to take of M into L square into theta dot square. So theta dot square is 2 times of theta dot into theta double dot. Yeah. Sorry. Yeah, so 2 times of theta dot minus, so this is dou L by dou theta dot. Similarly, dou L by dou theta is given as minus mgl into derivative of cos theta is minus sin theta. So minus of minus will be plus sin theta. So this is, after substitution from this equation, d by dt of m L square into 2 times of theta dot minus mgl times of sin theta. So this is half m L square into 2. So 2 will cancel out. And then theta double dot or d square theta by dt square plus mgl sin theta equal to 0. So this m will go for 0 and 1l will go for 0, and then d square theta by dt square is equal to minus g by l times of sin theta. So for small values of theta, sin theta can be equated to theta. So the equation of motion is d square theta by dt square is equal to minus k theta, where k is equal to g by l. Got it? Understood? Any questions on this? Any questions on this? Okay, great. Okay, fine. So note it down. Okay. So let us take a little complex than this. Note down this. Derive the equation of motion. Derive the equation of motion of a bead on the cycloid using Lagrangian whose coordinates are given as, whose path is given as x is equal to a into 1 theta minus sin theta and y is equal to a into 1 minus cos theta. Can I derive the equation for this with the help of Lagrangian? This is the complex level you can expect. So I hope you are aware of the path of a cycloid. Cycloid actually, the curve that is generated when so wheel is moving. Suppose if there is a wheel like this, so this is the wheel. Now put a dot on this particular wheel. Now this dot, put a dot on the wheel. This dot actually will traverse a path when this side in this wall is when this circle is moving like this. So if this is rotated and moving, so like this actually if it is rotated and moving like this, the path that is going to be traversed by this particular identity is nothing but the equation of this cycloid. So this is how it is going to like this, right? So this is continuously moving. So when it is moving like this, so it is having one position at any instant. Like this actually, this ball is trying to move. Got it? So this is the dot. This is the dot. So this dot actually continuously moving like this, right? So when this dot is moving continuously, when this is the wall, so this is how the dot is traveling. So all these points are the path of the dot. So this is the dot. Got it? So the path I am highlighting it here. This is the path of travel. So on this path of travel, so the dot coordinates, suppose at any instant, So let us say x comma y are the coordinates. These coordinates are given by these equations for that particular dot where it is moving. Now, with this information, he asked us to find out the equation of motion for this particular dot. So this dot is nothing but the bead. Got it? So for that actually, so what you need to identify here it is, so when we are talking about the displacement, right? So the displacement actually you have to be traversing on this particular line. Now these are the x comma y coordinates of that particular point. Now when it is moving on a path, so this is traversing a displacement of s. So this is the s, that is the path. So the path is s. The path direction, now actually if you want to find out the magnitude of s that is getting traveled is given by dx actually if you take it. So dx is a into derivative of cos theta is, so derivative of theta is 1, dx by d theta. So this is a times of derivative of sin theta is cos theta, and then dy by d theta is given by a sin theta. Now dx is given as a into 1 minus cos theta into d theta, and dy is given as a sin theta into d theta. Now ds square, where ds is this elemental length. So this is the elemental length ds, and this ds value will dependent on dx and the vertical length dy. So dx is a into 1 minus cos theta into d theta, and dy is a into sin theta. ds square is dx square plus dy square. This methodology actually we have used in case of statics when we dealt with the catenary equation. So the same methodology actually we have adapted there to find out the path traveled or the length of this string actually which is in a catenary form, right? So that time actually we have used the similar methodology. So dx is equal to a into 1 minus cos theta into d theta, dy is equal to a into sin theta into d theta. Now here dx square plus dy square is a square, if you take it out, 1 minus cos theta whole square plus sin square theta into d theta whole square. So this value a square into 1 plus cos square theta minus 2 cos theta plus sin square theta into d theta whole square. So this is a square 2 minus 2 cos theta into d theta whole square. So this value is a square into 2 times of 1 minus cos theta into d theta whole square. So this is 2a square, 1 minus cos theta can be written as, so 2 sin theta, 2 sin square theta into d theta whole square. So this is 2a sin theta d theta whole square, 2a sin theta d theta sin theta by 2, sorry, it's not theta, it's theta by 2, yeah, sin theta by 2 whole square. This is ds square. So it implies ds can be written as, ds is equal to 2a sin theta by 2 d theta. So we have got the path of travel equation. Now this one, if you integrate on either side, you are going to get the value of s, which is nothing but the length of the path. So this s value, so s is nothing but integral of 2a integral sin theta by 2, and then this theta is varying from, so initial when this is the one, so this is theta angle is pi, and from pi actually when it is rotated complete, this is 2 pi. Now at any random point if you take it, the angle it is going to take it, this is theta, this is the angle theta, right? So this angle is taken from the initial line, so this is the angle pi to theta, it is the variable length. So this s value at any instant, at any angle if you want to find out, so theta is varying from pi to angle theta. Now here s is equal to 2a times of integral pi to theta sin theta by 2 d theta. So integral sin theta is minus cos theta So this is minus 2a cos theta by 2 divided by 1 by 2. So this will be 4 times of a cos theta by 2. Upper limit is theta, lower limit is pi. Now this value is minus 4a times of, so theta is substituted cos theta by 2 and the lower limit is pi by 2, cos of pi by 2 will become 0, we can ignore that way. So S value is given as minus 4a cos theta by 2, right? So this value is coming as minus because theta by 2 and theta is in between pi to 360. So the angle, even if you put it, minus of minus will come as plus for us. Got it? So this way actually you are able to arrive at the point of the calculation of the perimeter. Perimeter is nothing but the path of the travel. So this path of travel actually we were able to identify. Now based on this understanding, when you wanted to express the equation of motion, so the velocity that needs to be taken along this particular line. So that is nothing but d square, so ds by dt is the velocity. And then theta dot is nothing but s dot, right? So q dot you have to take as s dot and s double dot is the term which you need to adopt in the final equation, right? So that's why you have to identify the value of s first based on this understanding. Once you identify it, then you can identify the Lagrangian as half mv square where v is s dot. Got it? Understood or not? So note down till this point, then we are going to find out the Lagrangian based on this s value. Note it down. Why we have calculated dx and dy and then integrated? Because, so this is the methodology that we adopt in finding out the catenary length in any case. Got it? How theta limit repeat? Where is that? Where did we repeat the theta limit? So Deepak, you got the clarity, right? Why we have calculated dx and dy? This is the methodology usually we adopt in finding out any perimeter length in case of any non-standard direction. Got it or not? Yeah. So how theta limit is repeated? Where? Keshav, where is your doubt? So we never repeated theta limit actually. So these limits are theta varying from pi to 2 pi. In between, if any random theta value is taken, so this is like this. So this theta value actually we will have to put it in integrating it so that it is varying from when pi, so theta angle is pi to some other value. If it is changed, then what is the path of travel? That you are going to get it with the help of this equation. Got it? Okay. So noted. So this is the fundamental thing that you have to be aware, so that actually you will be able to find out the Lagrangian easily. So S value we have got. Now, so from S actually the potential energy, sorry, the kinetic energy T is given as half m into v square. V is nothing but ds by dt. This is exactly the reason actually we brought this into picture. So ds by dt. For that we need this s value. So ds by dt is nothing but the kinetic energy, and then the potential energy PE is given as, so here what is this length? The top to bottom length, what is this length? So that is nothing but the value of y which is having the maximum value, that is, so this can assume a maximum value of 2a, right? Yeah. So this length is 2a. Now when this length is 2a, then obviously, so this value or the height actually at any random point, if you want to find out this height, so this is the value of y. Now when you want to find out the potential energy, this is nothing but mgh, right? So mgh is the reference. Now when we calculate the potential energy, usually you take from any one reference. So this you can take as, so this is mg into 2a minus y, right? 2a minus y is the value of h. So this y is not this one. Yeah. From the vertical actually if you take it, this value is y. Now the height is this one from the bottom. So because when you calculate the potential energy, it is always trying to drop down. Now if you take this as the reference, the height that is getting traveled by the bead at any instant is given by this h, which is nothing but 2a minus of y. Got it? Understood or not? Is this understood? Yeah. So once you understand that this y is nothing but given by this equation, so the potential energy V is equal to mg into 2a minus, so y value is a into 1 minus cos theta. So this value mg into 2a minus a plus a cos theta. So this is mg a times of 1 plus cos theta. So 1 plus cos theta can be written as 2 cos square theta by 2. So mg a 2 times of cos square theta by 2. Now here cos theta by 2 is nothing but s by 4a. So this is cos theta by 2 minus of. Now if you square it, here if you replace it, this is 2 mga into s by 4a minus of whole square, right? So this is 2 mg a s square divided by 16 a square. This 2 a square and this one will cancel out, and then this goes 8 times. Then whatever you are going to get, it is, so m by 2 if you take it out, then g times of s square g by 4a times s square. So this is the potential energy V. Got it? Understood? So m by 2 times of g by 4a s square is nothing but the potential energy, and the kinetic energy is given as half m into ds by dt whole square. So this is the kinetic energy. Now based on this understanding, you can find out the Lagrangian as the potential kinetic energy minus the potential energy. So you have to find out this L value and then apply the Hamiltonian equation of Leeds. How to a? So this is the maximum value that you can get at this particular point. So this height is given as, so this value, maximum value of this is, if you simplify this, 2 sine square theta by 2. So 2 sine square theta by 2, 2a into sine square theta by 2, and sine square theta by 2 maximum value is 1. So hence y is going to be 2a, that is the maximum value it can assume. Got it? Summary? So you understood what is potential energy and kinetic energy in this aspect? Okay, so once you get the kinetic energy and potential energy, I'll write the Lagrangian. So the kinetic energy is half m into ds by dt whole square, and the potential energy V is given as half m into g by 4a times s square. So this is the potential energy. Now from this, the Lagrangian is L is equal to T minus V. So this is m by 2 if you take it out, then s dot whole square minus g by 4a times of s square. So this is the Lagrangian. So dou L by dou theta dot s dot is given as m by 2 times of 2s dot, and dou L by dou s is given as m by 2 times of minus g by 4a into 2s. So this is, these two will cancel, minus mg by 4a times s. So this is, and if you substitute the Lagrange, so Hamiltonian principles of least action, d by dt of dou L by dou s dot minus dou L by dou s is equal to 0. Now here d by dt of, so m by 2 times of 2s dot, so these two will cancel, and then minus mgs by 4a is equal to 0. Now this is m into s double dot minus mgs divided by 4a is equal to 0. So minus of minus here, this will be plus. So m will cancel out, s double dot plus gs divided by 4a is equal to 0. So this is the equation of motion, or in general d square s by dt square plus g by 4a times of s is given as 0. So this is the equation of path of travel of the bead, path of the, in case of cycloid. Understood? Got it? Any questions on this? So these are the kind of questions actually you can expect in case of mechanics, wherein the concept is simple. Only thing is you have to be aware of the generalized coordinates and the, so, and then the holonomic constraints you have to be aware. From there actually Lagrangian needs to be defined. From the Lagrangian, so you have to use the Hamiltonian principle of least action to find out the path of travel for any kind of particle, whatever it is. Got it? Any questions on this? Got it? So this should be simple only, right? Okay, so that's all for today. So this is about the mechanics. Hope you understand clearly. So I have covered each and every aspect. So if you have any questions, you can let me know. So this will be the last class for mechanics, right? And then partial will be the next class. So I have finished with this mechanics, right? So in the partial actually, yeah, I think so it won't take much of time. So because actually almost every concept is known, so I don't take much time. So maximum 10 classes we will finish it off. Yeah. Got it? So this batch actually introduction to the partial differential equations next class. Yeah. Yeah. So partial differential equations, so it won't take much time there. So because actually almost everything is known. So three applications, one is the vibrating string and another is the heat equation, another is the Laplace equation. So those three equations actually which comes under the applications of partial differential equations, and the basics of partial differential equations contains one is the formation of the partial differential equations, that is one aspect, and another aspect is finding out the solutions of quasi-linear partial differential equations, that is one aspect, and another aspect is the linear differential equations, and then Cauchy's method of characteristics and canonical form. So that's all as part of partial differential equations. So each will take 1 hour or maximum 2 hours. Yeah, got it. So that's all for today. Yeah. So thank you. A good night.